Imagine an AI agent that never forgets what it learns, where each interaction makes it smarter. We're talking about a production-grade agentic RAG. Usually we see something like this when it comes to the RAG pipeline. A request will be sent to the agent. An agent uses the RAG system to retrieve the information and return it back to the user. However, this is not efficient because we can change this architecture and use another agent to remember the previous results. So in the future, if a new request came, instead of sending a request to the API, we just send the request to our database, to our memory, and return previous information from there. Or even if we are sending the request to the API, there are more information in our memory that we can combine them together and give a better response to the user. I'm going to build this project using LangGraph, Tavily, and Pinecone database to store the memory. Pinecone is really powerful when it comes to large-scale similarity search with low latency. Now that you know what is the difference between naive RAG and agentic RAG, let's build this project. The first thing is to set the environment variable for Tavily, Pinecone, and OpenAI. Then we set the configuration for all of them. We need to have the embedding model, which I'm using the text embedding 3 small, and also GPT-4o mini for the OpenAI, and also for the Pinecone, this is the configuration to get the API key and pass it to the Pinecone function. Also, we need to use the Tavily API key and define the Tavily function. After setting up the configuration, we need two more functions. One for ingesting the memory to the Pinecone and one for retrieving that memory from Pinecone. To ingest the memory, we need to define this function where we're calling the Pinecone and defining the index. You can find this in the Pinecone documentation, which I put the link in the description. And here we have our main function. What is happening here is pretty simple. We are embedding the input query, which in our case is the memory that we want to save to the Pinecone. And then we append all of those embedded vectors to our vector variable, and then we observe it to the Pinecone. Simple and straightforward. For retrieving, we do almost the same, except after embedding the input query, we just use another function to search for the top k samples, vectors actually, top k vectors, similar to the input query. But this is just the beginning. What we need to define our agent. These two functions will be used as the tools of our memory agents. So this is the tools, and we have two different tools here. One for adding the memory and one for searching the memory. And you see that. This is the function for retrieving we defined already. And this is the function we defined to insert those memories to the Pinecone. This is our prompt, our system prompt, and our agent, which is pretty simple. We're just calling the create React agent from LangGraph pre-built and passing the tools, naming our agent, passing the prompt, and the LLM. We do the same for our researcher agent, except here for the researcher agent, as a tool, we need to define the Tavily search engine. For the prompt, we just define a system prompt that is pretty simple. And here is the agent. Everything is the same, just the tool and prompt is different. Now that we have our memory and researcher agent, we need to define the supervisor agent to supervise these two agents. So first thing is the system prompt, which I defined a chain of thought system prompt and defined everything that this supervisor agent should do and how is the response format and all the examples and other stuff in the system prompt. And then here we have the agent, the create supervisor from LangGraph supervisor, and passing the agents model supervisor system prompt and the output that we want, which is going to be full history. At the end, we just compile the supervisor agent. Why? Because we need to define this agent as a node in our graph, and pay attention that you must compile it. You cannot pass this to the graph as a node. It must be compiled before passing to the graph. Also, don't forget to define your state, which here in our case is just a simple input and the list of messages. And for those who doesn't know what is the use case of a state, in LangGraph, the term state usually refers to the shared memory that flows through your graph of agents. Like, think of it like a blackboard where each agent can read or write information as the workflow progresses. Now that we have all pieces of our puzzle, we just need to run our graph. We call our graph. This is the message I'm going to ask the question and passing to my graph. Let's run this. And here is our response. Let's see what happened. This is our question. Supervisor said, first, let's analyze the question. And then it transferred our question to the memory agent, because this is the priority I defined already in the system prompt of the supervisor. If response exists in the memory, we shouldn't transfer to the research agent. Memory agent returned those memory that are similar to our questions, but at the end the reasoning was no complete information found in the memory regarding the best framework. This response went to the supervisor, and supervisor said that since there is no relevant information, it's better to route to the research agent. So research agent has our question, and after searching, it returned the responses. And now our supervisor has that response and returned the final response to us. So what I want to do now is to save this information into memory for future. So I say save this information to memory. The information is embedded and successfully transferred to memory agent, and the information regarding the best framework for developing Agentic AI has been successfully saved to memory. Let's check our Pinecone and see if this information is there or not. This is our Pinecone database, and this response is our last response that we ask our agent to save it to the memory. And that's how you can design an agentic RAG. Feel free to ask me any question that you have in the comments. I will answer to all of them. And thank you for watching this video. Please share it with your friends, like and subscribe. These are the things that give me motivation to make more video like this for you guys. Take care and see you in the next video.